Hello students, this is our 5th class through my YouTube channel Center for Chemistry Kollam, and in the previous classes we discussed about the concept hybridization and different types of hybridization such as SP, sp2, sp3 and sp3d. In this class we can discuss a new hybridization, sp3d2 hybridization, and some shortcut to determine hybridization for simple molecules. So first we can discuss about the shortcut method to determine hybridization and shapes of simple molecules and ions. Okay. So steric number is equal to half into V plus M minus C plus A. Steric number means number of hybrid orbitals. Number of hybrid orbitals around the central atom. Or steric number is the number of atoms or groups attached to the central atom and lone pairs of electrons. Total number of atoms or groups plus lone pairs of electrons around the central atom is called steric number, or it is the total number of hybrid orbitals around the central atom. Steric number half into V plus M minus C plus A. V is equal to number of valence electrons present in the central atom, and M is the monovalent atoms connected to the central atom. C cationic charge, A anionic charge, charge on the anion and charge on the cation. So we can discuss in a shortcut way the hybridization and the shape of these simple molecules and simple ions by using this formula. So first molecule, beryllium difluoride. Beryllium difluoride. So Sn, steric number is equal to number of hybrid orbitals around the beryllium. So this is beryllium difluoride. This is beryllium. Number of hybrid orbitals around the beryllium is a steric number. So Sn is equal to half into number of valence electrons in the central atom beryllium. Beryllium, magnesium, calcium, strontium, barium and radium belongs to group 2. So group 2 elements possess 2 electrons in the valence shell, group 2. So number of valence electrons 2. Plus number of monovalent atoms connected to the central atom. Central atom beryllium. Number of monovalent atoms 2 beryllium atoms. So 2. So this is a neutral molecule and these two are not applicable. Cationic charge and anionic charge. Minus 0 plus 0 is equal to 4 by 2 is equal to 2. 2. So these are the valence orbitals. S orbital, 3p orbital and 5d orbitals. 1, 2, 3, 4 and 5. S, p and d. So steric number means a number of hybrid orbitals 2. There is a no lone pair of electrons here. 2 orbitals for 2 bond pairs also. So 2 orbitals means hybridization 2 orbital, sp hybridization. So hybridization is equal to sp. 2 hybrid orbital. These 2 hybrid orbitals are utilized for making these 2 bond pairs, BEF bond pairs. So hybridization sp. So this is AX2 type molecule. AX2 type. A is the central atom and X are the connected atom. AX2 type. For AX2 type, hybridization sp. So 2 hybrid orbital sp. We discussed earlier. So this is beryllium, sp hybridization. and two fluorine atom will connect here, two fluorine atom and fluorine atom, two fluorine atom, a pair, sp hybridization, beryllium difluoride, shape linear, bond angle 180 degree for AH2 type. Hybridization here sp, shape linear, beryllium, two hybrid orbitals are oriented along a straight line with a bond angle 180 degree, and two fluorine atom will overlap with this hybrid orbital. So this overlapping is sp-p overlapping. This is also sp-p overlapping, beryllium difluoride. So hybridization sp, and the shape of this molecule is linear, shortcut method. So second molecule BF3. Second molecule BF3. So steric number is equal to half into boron, aluminum, gallium, indium, thallium, 13th group elements. So valence shell 3 electrons. Valence shell of 13th group elements contains 3 electrons. So number of valence electrons for central atom 3, plus a number of monovalent atoms connected to 3. So this is a neutral molecule, minus 0 plus 0. So is equal to 6 by 2 is equal to 3. So hybridization, sp2 hybridization. sp2 hybridization. So BF3. So molecule is a planar. Molecule is a planar with a bond angle 120 degree. Molecule is a planar with a bond angle 120 degree. sp2 hybridization. Shortcut way. Hybridization sp2. Shape planar. Bond angle 120 degree. That about a BF3. So next molecule, methane CH4. Methane CH4. So steric number is equal to half into central atom carbon, carbon, silicon, germanium, 14th group, 4 electron in the valence shell of carbon, monovalent atoms, 4 hydrogen atom, 4, neutral minus 0 plus 0 is equal to 8 by 2 is equal to 4. So hybridization sp3. 4 means 1, 2, 3, 4. Hybridization sp3. Shape tetrahedron. Shape sp3 hybridization. Methane. This is CH4 methane. And this is sp3 S overlapping for CH bonds. Shape tetrahedron. Shortcut. Very simple way using this formula. Steric number is equal to 4. 1, 2, 3, 4. Hybridization sp3. So this is methane. Next ammonia. NH3. Fourth molecule ammonia NH3. So steric number is equal to number of hybrid orbitals around nitrogen. So Sn is equal to half into nitrogen, phosphorus, arsenic, antimony, bismuth, 15th group. They contain 5 electrons in the valence shell. Nitrogen 5 electron in the valence shell. Monovalent atoms 3. So plus 3. This is a neutral molecule, minus 0 plus 0. Is equal to 8 by 2 is equal to 4. 4 hybrid orbitals around the nitrogen. 4 hybrid orbital. 3 for hydrogen and 1 orbital carry a lone pair. So 4 can be divided into 3 bond pair. 3 orbital for bond pair for 3 hydrogen and 1 a lone pair. 1 lone pair. So this is a AX3 E type molecule. A stands for nitrogen, X here X3 for 3 hydrogen and also a lone pair. AX3E means the shape pyramidal. So NH3 is under, in NH3 N is under sp3 hybridization. 3 orbitals for hydrogen and the 4th orbital is with a lone pair of electrons. 4 orbital. 1, 2, 3, 4. This is about ammonia. So shape pyramidal. 4 hybrid orbitals. 3 orbitals for bond pair and 1 orbital carry an unshared pair. So this is AX3 E type. AX3 E type, we know the shape is pyramidal. The bond angle 107 degree. 107 degree. Ammonia is pyramidal. sp3 hybridization. Nitrogen atom. Next H2O molecule, water. Fifth molecule H2O. H2O molecule. So central atom oxygen. So half into steric number. Half into oxygen, sulfur, selenium, tellurium and polonium. 16th group, valence shell 6 electrons. 2 monovalent atoms, hydrogen plus 2. Neutral molecule 8 by 2 is equal to 4. So around oxygen 4 hybrid orbitals. 4 hybrid orbitals. Oxygen. 2 orbitals for hydrogen. 2 orbitals for hydrogen. And remaining 2 orbitals carry lone pairs. 4 orbitals. 2 orbitals for hydrogen atom. H will overlap here and H will overlap here. So this is the molecule water. OH, H and with the 2 lone pairs. So shape angular or V shape bent molecule water. Type AX2E2 type. A stands for oxygen, X2 2 hydrogen and 2 LPs lone pairs. Shape AX2E2 type molecules are bent molecule, angular or V-shaped molecule with bond angle 104.5 degree. Water molecule. So this is the water. 4 orbitals. 4 orbitals means hybridization sp3. Out of 4 orbitals, 2 orbitals are used for making bond pairs, OH bond. Remaining 2 orbitals carry unshared pair. Outermost shell of oxygen contains 6 electrons, 2, 4, 5 and 6. This is about water. AX2E2 type, hybridization sp3. Shape angular V shape and the expected shape tetrahedron. Actual shape angular or V due to the presence of these 2 lone pairs. I expected bond angle, tetrahedral angle 109 degree 28 minutes. That reduces into 104.5 degree due to LP repulsion. NH4 plus a cation. So NH4 plus 6th ion, a simple ion NH4 plus. So steric number. Steric number means number of orbitals around hybrid orbitals around the nitrogen. This is nitrogen central atom. We can determine how many hybrid orbitals are present around the nitrogen in NH4 plus. So shortcut formula half into nitrogen, phosphorus, arsenic, 15th group, 5 electrons in the valence shell. Monovalent atoms is equal to 4. This is a cation. Cation means to lose 1 electron from its valence shell. We have to lose 1 electron. Remove 1 electron from the valence shell. That means a minus 1 plus 0. Minus cationic charge. NH4 plus. So Sn is equal to steric number is equal to half into 5 plus 4, 9 minus 1 is equal to 8 is equal to 4. This means 4 hybrid orbitals are present around the nitrogen. And these 4 hybrid orbitals are bond pairs because of 4H plus. 4H plus tetrahedron. 4 hybrid orbitals are carried by 4 H atoms. And this is NH4 plus. 4 orbitals, 4 bond pairs. So shape tetrahedron. Shape tetrahedron. Nitrogen is under sp3 hybridization. There is no lone pair. 4 H atoms are attached to central N atom. It has 4 hybrid orbitals. And ammonium ion shape tetrahedron. And the tetrahedral angle 109 degree 28 minutes. Next, 7th molecule is an ion H3O plus. Number 7, H3O plus. Central atom oxygen. How many hybrid orbitals are present around central atom oxygen? Steric number is equal to half into oxygen, central atom. Outermost shell contains 6 electrons plus monovalent atom 3 hydrogen atom. A positive charge minus 1 plus 0. So 9 minus 1, 8 by 2 is equal to 4. 4 hybrid orbitals around oxygen. 4 hybrid orbitals. 4 hybrid orbitals around oxygen. And 3 orbitals are H plus, H3 plus, and a lone pair, an unshared pair. This is H3O plus, H3O plus. This is oxygen carrying a positive charge. So this is type AX3 E type, like ammonia, NH3E. So shape pyramidal, shape pyramidal, shape pyramidal. Oxygen is under sp3 hybridization. Expected shape tetrahedron, actual shape pyramidal due to the presence of a lone pair, and bond angle is not 7 degree due to lone pair bond pair repulsion. Expected bond angle 109 degree 28 minutes, and this is about hydronium ion H3O plus. So we can determine number of hybrid orbitals around oxygen. Its number is equal to hybridization. So next, OF2, oxygen difluoride. Oxygen difluoride, 8th molecule, oxygen difluoride. So central atom oxygen, and the 2 fluorine atoms are connected to it. So how many hybrid orbitals are present around oxygen? That is steric number. Steric number is equal to half into. Oxygen belongs to 16th group, 6 electrons. 2 monovalent atoms, fluorine atoms. Neutral molecule minus 0 plus 0. And this is the formula. So a number of monovalent atoms is 2. So 8 by 2. 8 by 2 is equal to 4. That means around oxygen 4 hybrid orbitals. 4 hybrid orbitals around the oxygen atom. 4 hybrid orbitals. So hybridization, sp3 hybridization. sp3 hybridization. 4 hybrid orbital. And 2 orbital is occupied by fluorine atom. Fluorine. 2 in 2 orbitals fluorine atom. OF2. 2 orbital carry lone pair of electrons. So this is OF2. This is OF2. 2 lone pairs. OF2. 4 hybrid orbitals around oxygen. 2 orbitals for 2 orbitals carry bond pairs, and p orbitals of fluorine overlap here. P orbitals of fluorine overlap here, and OF2 is formed with 2 lone pairs. So type AX2E2 means like water, H2O type molecule, AX2E2. So shape angular or V bent molecule. Hybridization sp3. Actual shape V or angular, OF2 molecule, V shape. Expected shape tetrahedron. That about OF2. Next, PCl5. We already discussed that PCl5 molecule. A neutral molecule PCl5, 9th molecule PCl5. So how many hybrid orbitals are present around phosphorus? So Sn is equal to steric number half into phosphorus 15th group of 5 electron in the valence shell. Monovalent atom also 5, minus 0 plus 0 neutral molecule, 10 divided by 2 is equal to 5, hybridization sp3d. 5 hybrid orbitals around phosphorus. 5 hybrid orbitals around phosphorus. 5 hybrid orbitals. Double shaped 5 hybrid orbitals. And 5 chlorine atoms also present. So shape trigonal bipyramid. The bond angle is 120 degree and 90 degree. This is PCl5. Shape trigonal bipyramid. 5 hybrid orbitals. Cl of 3. Chlorine trifluoride. 10th molecule. Chlorine trifluoride. Central atom chlorine. How many hybrid orbitals around the chlorine? So steric number is equal to half into chlorine 17th group halogen 7 electron plus 3 monovalent atoms neutral minus 0 plus 0. 10 by 2 is equal to 5. So hybridization sp3d. So around chlorine Around chlorine 5 orbitals. 5 orbitals means trigonal bipyramid. 3 orbitals for fluorine. 3 orbitals for fluorine atom. And 3 orbitals for fluorine atom. 3 bond pair. 3 bond pair. Plus 2 lone pair. 2 lone pair. 3 bond pair and 2 lone pair. Cl of 3. Yes. 2 lone pair. 2 lone pair. 2 LP. The 2 lone pairs are present at the equatorial base, equatorial position. 2 lone pairs. And 3 bond pairs, 3 fluorine atoms are present here. In order to minimize the repulsive force. 120° repulsive force minimum, and the lone pairs are present in the equatorial position. And this is, and 3 bond pairs are here. And the shape. So this is chlorine, central atom chlorine, 2 fluorine, 2 fluorine, last fluorine. So shape and with the 2 lone pairs. So take shape T shape, T shape. But lone pair repulsion is strong. Lone pair bond pair repulsion, lone pair bond pair repulsion. So a bendity with the 2 lone pair here and here. And this is chlorine, 2 fluorine atom. T shape bendity due to lone pair repulsion. This is about ClF3. ClF3. Hybrid orbital total steric number. So next CO3 2 minus. CO3 2 minus carbonate ion. CO3 2 minus. Carbonic acid H2CO3. Potassium carbonate K2CO3 carbonate anion. So number of hybrid orbitals around the carbon, that is steric number is equal to half into carbon 4 electron in the valence shell. Number of monovalent atoms, oxygen is bivalent. Number of monovalent atoms around the central atom, oxygen is bivalent. So 0. So minus 0, this is an anion, plus 2 minus, plus anionic charge, 2 electron excess. So steric number is equal to half into 6 is equal to 3. 3 hybrid orbitals around the carbon. So hybridization sp2. 3 hybrid orbitals means hybridization sp2 hybridization. sp2 hybridization. So shape planar. Carbon CO3 2 minus. So shape planar, bond angle 120°. CO3 2 minus. Hybridization sp2. Shape triangular, bond angle 120°. This is about CO3 2 minus. Next SO4 2 minus. SO4 2 minus. Central atom sulfur. SO4 2 minus. How many hybrid orbitals are present around the sulfur atom? So sulfur. How many hybrid orbitals? Sulfur. Sorry, Sn is equal to steric number half into oxygen sulfur 16th group. Oxygen is bivalent. Number of monovalent atoms 0. Minus C 0 plus 2 is equal to 6 plus 2, 8 by 2 is equal to 4. Hybridization sp3. 4 hybrid orbitals around the sulfur. So shape tetrahedron. SO4 2 minus. SO4 2 minus. SO2 SO4 2 minus. This is SO4 2 minus, a shape tetrahedron. Sulfur is under which hybridization? sp3 hybridization. 4 hybrid orbitals around sulfur. This is SO3 4 minus. Next sulfur dichloride. SCl2, sulfur dichloride. So central atom steric. How many hybrid orbitals are present around the sulfur? That is steric number. So steric number is equal to half into 6 plus 2 monovalent atom. Chlorine is monovalent halogen. So 2 neutral molecule minus 0 plus 0 8 by 2 is equal to 4. So hybridization, sp3 hybridization. 2 chlorine atom. So out of 4 hybrid orbitals, 2 BP bond pair for 2 chlorine atom and 2 LP, 2 lone pair. So 4 hybrid orbitals around sulfur. 2 bond pair and 2 lone pair. 2 lone pair and 2 bond pair and SCl2. SF2 also same shape. So this is the shape. Type AX2E2 type. Like water, it is also angular or V-shaped bent molecule. SCl2. Hybridization sp3. Expected shape tetrahedral. And expected bond angle 109 degree 28 minutes. But here bond angle is less than 109 degree 28 minutes due to lone pair repulsion, and the shape is not tetrahedral due to the presence of these 2 lone pairs. Actual shape is bent or angular or V shape. That about the SCl2. Next the SF4. SF4. Sulfur atom. How many hybrid orbitals are present around the sulfur atom in SF4? Or sulfur tetrafluoride or sulfur tetrachloride? Sulfur. So Sn is equal to steric number, half into sulfur belongs to 16th group, 6 valence electron. So SF4, 4 monovalent atoms, 4 neutral, -0 plus 0. So 10 by 2 is equal to 5 hybrid orbitals, 4 bond pairs. So 4 BP plus out of 5, 4 bond pairs to 1 lone pair of electrons. So around the sulfur atom, around the in SF4, around the sulfur atom, 4 bond pair and 1 hybridization sp3d. Hybridization sp3d. 5 hybrid orbitals. 5 hybrid orbitals. And 1 lone pair. 4 bond pairs. So lone pair is present in the equatorial position to minimize the repulsive force according to BSEPR theory. So SF4. This is SF4. And this is also SF4. SF, 4 bond pairs. F and 2 fluorine atom like this. Seesaw model. Shape seesaw. You can see in children's park seesaw. Children sit on the both side, both the end, and swing up and down. Sit to both end. Children sit to both end and swing up and down. You can see in the children's park this. So shape seesaw shape, and the 2 lone pairs also present here. This is SF4. Hybridization sp3d. The expected shape trigonal bipyramid. Actual shape seesaw or distorted tetrahedron or seesaw shape. And lone pair repulsion. Lone pair according to BSEPR. Due to the presence of these 2 lone pairs, actual shape becomes a seesaw. The expected shape trigonal bipyramid. This is about SF4. And the last molecule, SF6, we can discuss in detail a new hybridization. SF6. First we can, in a shortcut way, we can determine the hybridization. Half into SF6. Sulfur, central atom, means 6 valence electron. Monovalent atom also in 6 plus 0 minus 0 plus 0. 12 divided by 2 is equal to 6. 6 means hybridization, sp3d2 hybridization. So we can discuss in detail this molecule, the new hybridization. So far we discussed sp, sp2, sp3 and sp3d. A new hybridization, sp3d2 hybridization. This is a shortcut method, SF6. SF6. Central atom sulfur. Atomic number 16, 1s2, 2s2, 2p6, 3s2, 3p4, 3d0. And this is the valence shell. Electronic configuration is called ground state electronic configuration. Ground state electronic configuration. 3s2, 3p4 according to Hans rule. 3p4, 3p4, 3px, 3py, 3pez, 3pez, 1, 1, 1, 1, 3p4 and 3d orbital. 1, 2, 3, 4 and 5, 3d0. SF6. Sulfur is hexavalent in SF6. Sulfur is hexavalent. Sulfur. 6 fluorine atoms. 6 fluorine atoms around sulfur. 6 electrons. So we need 6 electrons in the valence shell. 6 free electrons. So no combining capacity, no combining capacity. Combining capacity in this way, sulfur can produce SF2, not SF6. Only 2 half-filled orbitals. To produce SF4, this electron is promoted to this shell. Excited state electronic configuration. So 3s2, 1, 2, 3, 4 and 5, 3px, 3py, 3pz. And when this electron is promoted, and this is the stage, sulfur can produce SF4 in this way, SF4 or SSCl4, 1, 2, 3, 4, valency 4. To produce SF6, this electron is also promoted. So 6 electrons, free electrons in the valence shell, 6 electrons. Combining capacity 6, 1, 2, 3, 4, 6. So these 2 pairs are excited to the 3D level. And after that, after excitation, central atom undergo which hybridization? sp3d2, new hybridization, sp3d2 hybridization. sp3d2 hybridization. 1s, 3p and 2d orbitals are involved in this hybridization, and this hybridization is called sp3d2 hybridization. 6 orbitals are involved. 1, 2, 3, 4, 5 and 6. And 6 hybrid orbitals are produced. 6 hybrid orbitals. 4 orbitals along the 4 corners of a square. 4 orbitals along the 4 corners of a square. 4 orbitals. And the remaining 2 orbitals in the axial position. Remaining 2 orbitals in the one above and another below. And this is sulfur. 6 hybrid orbitals. 4 along the 4 corners of a square and the remaining 2 in the axial position, one above and the other below the plane, each carry 1 electron. This is sulfur. 6 hybrid orbitals. And this is called octahedron. Octahedron. In an octahedron, 4 orbitals along the 4 corners of a square and the remaining 2 orbitals in the axial position, called bond angle 90 degree. Bond angle 90 degree. This is the hybridization sp3d2. So you define sp3d2 hybridization if 1s, 3p and 2d orbitals are involved in an intermixing. That hybridization is called sp3d2 hybridization. Here 6 hybrid orbitals are formed and these hybrid orbitals are oriented along this 6 corners of an octahedron with a bond angle 90 degree. So 1s, 3p and 2d orbitals, d and d. What are these d orbitals? There are 5 d orbitals. dxy, dxz, dyz, dx square minus y square, ds square minus y square and dz square. We can divide these 5 d orbitals. 1, 2, 3, 4, 5. Their names: dxy, dxz, dyz, dx square minus y square and dz square. We can divide these 5d orbitals into two sets. These three orbitals are called T2g orbital, and these two orbitals are called EG orbitals. We will discuss in coordination chemistry, crystal field theory, these things T2g orbital. For these three orbitals, the orientation is between the axes. For these three orbitals, dxy, dxz, dyz, orientation between the axes. These two orbitals, orientation along the axis. This is d square minus y square, and this is dz square. So here 2d orbitals are involved. 2d means with the same orientation, d square minus y square and dz square. So the orbitals here involved are the EG orbitals in sp3d2 hybridization. They are with a similar orientation. 2d orbitals are involved, d and d. So one is d square minus y square, and another is dz square orbital. In the next class, we will discuss a new hybridization, sp3d3. sp3d3 means a 3d orbital. 3d, 1, 2, 3, sp3d3. 3d orbitals means their orientations are same, dxy, dxz and dyz. If the hybridization is sp3d3, the d orbitals involved are dxy, dxz and dyz. If the hybridization is sp3d2, the d orbitals involved are the orbitals with orientation along the axis, the EG orbitals, d square minus y square and dz square orbital. If it is sp3d, if only one d orbital is involved, the d orbital involved is dz square, because their orientation is similar to that of p orbital, pz orbital. I discussed that on PCl5 molecule. So sp3d orbital d is dz square. sp3d2, the d orbitals are d square minus y square and dz square. sp3d3 means the three d orbitals involved are dxy, dxz and dyz. So this is the hybridization. Hybridization is sp3d2 hybridization. Then the incoming atom, SF6. Sulfur is ready with its 6 orbitals, 6 hybrid orbital. Sulfur is ready, 6 hybrid orbitals. 4 orbitals along the 4 corners of a square, and the remaining in the axial, 2 in the axial position, bond angle 90. So fluorine, incoming atom. Atomic number 9, configuration 1s2, 2s2, 2p5. 2p5 means 2px2, 2py2, 2pz1. This is 2p5. So the half-filled orbital 2pz1 will overlap here with its electron, and it also becomes full-filled. When this becomes 2, number of electrons becomes 10, the configuration becomes 2,8, that of neon. So 2pz, fluorine. Next fluorine atom overlap here. Next fluorine atom here, here, here and here. And the SF6 is produced, 6 fluorine atom with its 2pz orbital overlapped with the sp3d2 hybrid orbital of sulfur, and the SF6 is produced, 6 fluorine atom overlapped here. And this is the spectrum of the molecule, and this is SF6 sulfur atom, and 6 bond pairs. 6 bond pairs, shape octahedral. Shortcut method also we discussed. The steric number is equal to half into V plus A minus C plus A. Again, Sn is equal to half into sulfur valence electrons 6 monovalent atoms. SF6, 6 monovalent atoms. Cationic charge is 0, anionic charge is 0, therefore 6 plus 2 is equal to 12 by 2 is equal to 6. 6 means hybridization, 6 hybrid orbitals, sp3d2. Yes, 3p and 2d. This is sp3d2 hybridization. What are the 2d orbitals involved in sp3d2? d square minus y square and dz square. So this is the new hybridization, sp3d2. 1s, 3p and 2d orbitals involved in an intermixing, and hybridization is called sp3d2. 6 hybrid orbitals, 4 along the 4 corners of a square, remaining 2 in the axial position, orbital orientation octahedral, and 6 fluorine atom connected to this hybrid orbital and SF6 is produced and shape octahedron. And this is about sp3d2 hybridization. Thank you very much. We can discuss another hybridization and shortcut method also in the next class. Thank you very much.